So for today's lesson, we're going to be going over the second lesson of the unit plan. So this one is Standard 6 EE2, and I'm going to go over the objectives for this lesson. So I have 5 of them. The first one is students should be able to comprehend letters that stand for numbers. The second one is students should be able to write expressions of operation pertaining to letters that stand for numbers. The third one, students should be able to identify parts of an expression as well as quote the identities and factors of an expression. The fourth one is students should be able to evaluate expressions as specific values and with real-world problems. And the last one is students should be able to perform order of operations and understand multiplication with parentheses. Now, as I said before, this is for 6th grade math. So what we're going to do is we're going to start with the vocabulary for the lesson. I got this from one of my cooperating teachers and it worked pretty well. So the first one is term. So this represents each factor in the equation or expression. So like we say here, we have 3. The first one would be 4x, the second one would be 7, and the last one would be 5. And it represents each term. Now for the expression, that's whatever comes before the equal sign. So in this case, it would be 4x minus 7 would be your expression. Now equation is the full thing. So it would be 4x minus 7 equals 5. So it includes all the terms, plus the subtraction sign and the equal sign. Now for a variable, this is any letter that represents or stands in for a number. So for this certain equation, 4x minus 7 equals 5, x will be your variable. Now the constant is 7 and 5 in this equation, but the reason that is because the reason why we don't mark 4 is because it is followed by a variable. So the constant is any number that stands by itself. Now since we backed up to 4 here, that is actually going to represent your coefficient. So your coefficient is any number followed by a variable. And now that we've covered that, we're going to move on to our algebraic expressions and blending in, putting those numbers and letters that stand for each other. So actually I have a worksheet that the students are going to fill out. We're only going to do a couple of them, and I kind of made up some of my own. And they will receive these and do these individually in the class, or they could do with partners. It doesn't really matter, whatever works well for both. And so we're going to start with A. So A will represent 3, B will represent 5, and C will represent B. Or 6, that's not B. Okay, so let's do a couple here so we can tell. Also, if you notice that multiplication with the 4 and B, there's no x in between, and that's because we now have variables and we wouldn't want to get that confused. So if you just stick the coefficient and the variable together, that means they're being multiplied. So in this case, we have 4b, so we see what b stands for, and that's 5. So it would be the same thing as saying 4 times 5. And another way you can represent multiplication is by parentheses. So if you have 2 constants, you can put the second constant in parentheses to know that it's being multiplied together. So we have 4 times 5, which equals 20. And that would be your answer. Now we have C over A. And if we notice, this looks like a fraction, but in this case, you would tell that this would be division. That's another way you can write division problems. So we have C stands for 6, and then A stands for 3. And then we could reduce that, and now you'd be able to divide. So we have 6 divided by 3 would equal 2. Okay, so now to the following problem. This one looks a little bit more difficult, but we are going to be using our properties. I know we haven't really talked about these before, but I know you've learned them before. So we're going to be using distributive property to solve this problem. So we're going to distribute the 2 to the b, and since we have parentheses, this represents multiplication. So we have 2 times b equals 2b. Then we have 2 times 1, so we have plus 2, and then minus a. So now we are going to plug in the numbers that represent. So here we have 2b, so b equals 5. So we have 2 times 5 plus 2 minus, and then a equals 3. So if we put this together, we have 2 times 5 equals 10, plus 2 minus 3. So 10 plus 2 equals 12 minus 3, and then 12 minus 3 equals 9. And that is our final answer. So for these specific problems, the students are just going to fill in the numbers for the letters given, and that'll kind of help them bring their process. And they have about, looks like 18 questions that they'll do on their worksheet. So for another part of this lesson, since we're going to be going over multiple topics, we are going to combine like terms with the coefficients in the variables themselves. So I did one already. So we have y plus y equals 2y, because this y represents 1y. So I think of it as an invisible 1 that's in front of each variable, so you know you have one of each. So we have 1y plus 1y equals 2y. And so now we're going to do some class participation and kind of see what we get here. Now we have 2x plus 4x. What would that give us?
6x.
6x. And we know that because we don't change this. This is not just 2x. We keep the variable the same. You just add the coefficients. Now we have x plus x plus x. It'd be the same as saying 1x plus 1x plus 1x. And what would that answer be?
3x.
3x, correct. Okay, and now we have 3y plus 1y. You can say 1y. So what would that answer be?
4y.
4y, correct? So the thing is, for this, for adding like variables, the students just want to remember that you're going to keep that variable the same for the answer. And so now we move on to one of our next worksheets. I didn't write anything down for this because this is more verbal than visual. So this is writing out algebraic expressions themselves. So like a problem that says Amy is 9 years younger than Jesse. Since we went over the vocabulary earlier, you want to know the sum and product. So sum is related to addition, and the product is related to multiplication. So the keywords in this worksheet, as you will tell, I put it in the lesson plan as well. They'll say 9 years younger, or 10 inches taller, or 5 times more. That represents addition, subtraction, and multiplication. So if we said Amy is 9 years younger than Jesse, we don't know how old Jesse is. So he is just going to be our variable. So let's say Jesse is x. So if he's 9 years younger, then that means we have to subtract 9 from that original age. Or if we said 10 inches taller. So let's say Liam is 10 inches taller than Tyler. So we don't know how tall Liam is, so he can represent, let's say, y. So taller, you're thinking more. So that means you're going to add 10 to that original age. Or if you say the length of the truck is 5 times more than the width. Whenever you see times more is when you're going to use multiplication. So if it's 5 times more, so here we don't have to use parentheses or the multiplication sign. Here it's 5 times more. Since we don't know the original, I'm going to use p. So it would be 5 times more, so it would be 5 times more than the original. So they will also have a worksheet on that they will be able to work together, and I can answer any of those questions for them. And so moving on to the last part of the lesson, I wanted to do PEMDAS is what I named this lesson. Please excuse my dear Aunt Sally. It's just something the kids can remember. I know I learned it, I think it was like either the 3rd or 4th grade. So maybe junior high, I can't exactly remember, but the P stands for parentheses, E for exponent, M for multiplication, D for division, A for addition, S for subtraction. So for PEMDAS, it is for the order of operations. So this will help them put in order correctly on how to solve a longer problem. So I put one up on the board already. So this one is 12 minus 8 divided by 4 plus 5 squared times 3 minus 10 minus 7 in parentheses. So following our PEMDAS here, we're going to start. So what are we going to start with in this equation?
10 minus 7.
Yeah, so we're going to start with our parentheses. So for me, it's always helpful to write out the full expression as you solve instead of just doing parts of it, or you might get confused. So I'm going to go ahead and rewrite it. So you have 12 minus 8 divided by 4 plus 5 squared times 3 minus, so what's 10 minus 7?
3.
Yep, so you're going to subtract whatever in that parentheses. Okay, so now we got the parentheses out of the way. What is going to be our next move in this equation?
The 5 squared.
Yes, we're going to get rid of our exponent. So what is 5 squared?
25.
Yep. So now we will plug in what 5 squared would be, and that would be 25. And one thing I did not mention earlier is that multiplication, division, and addition, subtraction, whichever one comes first in the equation is what you're going to do. So, according to PEMDAS, which would we do next?
8 divided by 4.
Yes. So what would 8 divided by 4 be?
2.
Yes. Since division would come first. Okay. Times 3 minus 3. Okay, so now which one would come next?
25 times 3.
Yes. And the students would be able to use their calculators. I'm not really picky about that. If they can't do that in their head, then they can do that. So what would 25 times 3 be?
75.
Yes. Okay. So now which one? We have subtraction and addition left. So which one would we do next?
12 minus 2.
Yes. So what would 12 minus 2 be?
10.
Okay. So now we have 10 plus 75 minus 3. So where would we go from here?
10 plus 75.
Yep. So what is 10 plus 75?
85.
Mm-hmm. So now we come down to our last two factors, which would be 85 minus 3.
82.
82. And that would be our answer. So if the students wouldn't have gotten this answer on their own, you would check their work to see if they maybe missed their step or they mixed up whichever ones came first, like the multiplication and division and the subtraction and the addition. So you kind of just know. And for me, like, it's always been good, like I mentioned before, to show your work. So as a teacher, you can see where they messed up. And I think another thing that I wanted to go over was finding the terms within the equation. So the students would be able to label, like, this is the coefficient, this is the variable, or say that this was the expression, and then you have equal to, or this whole thing is an equation. They would be able to label that and kind of get a hold of, just grasp those different vocabulary words. And for the closing, there was a game on MrNewsBomb.com that kind of goes over the order of operations. I did that game in the junior high, and it helped me a lot. It kind of gives the students a mission on, if you get the answers right, you get to save like someone, and then it moves on. And at the end, you've saved all the people. So I think that really helped me with learning which parts comes first. And it also just kind of helps the students grasp that concept and move on to the next criteria that they will be covering. So that is what I wanted to go over today. I'm sorry it's a lot, and the lighting's probably bad, but that's 6 EE2.